Hello everybody, good morning. Hi all.
Morning, sir.
Yeah,
Yeah, hi Shiva. Hi all, good morning.
good morning. So today is class 11 and yeah. So 1417. So these three are efficacy related, specific oncology related, efficacy related tables we are going to discuss. So what I suggest who are going with less experience like 2 plus 3 plus with your resume. So don't try to include the efficacy analysis related stuff in the your resume because how the industry is going. So whoever having the less experience, first they will focus on the safety because around 80 to 90% of any project safety related. The remaining 10% or 0% is efficacy related analysis related tables, listings, figures were included. So, who are having the more experience, like around, about 3 plus 4 plus. So, generally, those are the tough tables of efficacy. So, that is why they are assigned to the experienced candidate. So, that is what I am telling. Otherwise, if you want, you can put also no issues because even low experience, if you are putting also, they won't trust because around 1 plus 2 plus directly the efficacy related tables assignment was not given by the any company. Okay, so here I am explaining in depth, so from scratching to complete table about this efficacy analysis. So please try to focus on to understand that concepts. Okay, yeah. So sorry, let me open the SAS. Yeah, so let me open the mock shell. Yeah. So here summarize the objective response rate. It's a 1417. Why they are not? Okay. So here you can see the best overall response. Under this best overall response, what are the responses are there? Counts and percentages. Next, best objective response rate wise, the counts and percentages. And next, 95% objective responsive rate of A drug and B drug. And next one is difference of these two treatment comparison, 95% of object response rate comparison and p value. So we'll see what is what is what, etc. We'll see step by step. Yeah. So first we will focus on best overall response. Okay. So what is this best overall response? So let me show you. After that one, we'll go with the codes. So best overall response. Okay. So the best overall response definition is the best treatment response of a patient achieved during the clinical trial. Okay. So we are dealing with the oncology related means solid tumor related clinical trial. So in this solid tumor, the cancer tumor was present all of the subjects. Okay. So this tumor, for example, this tumor has around 10 mm of size. Okay. 10 mm of size. we are treating with our oncology related drug. Okay, so some patients are treating with A drug, some patients are treating with a B drug, like that. So at certain time point, so we will measure the tumor size again. Why? Because so on the day one, the tumor size is 10 mm, and at day 30, how the response was given by this tumor by treating with our drug. Okay, so if the tumor was completely disappeared from the body, so that type of response we can call it as complete response. Okay, that means what? Our drug is completely working. By using our drug, the 10 mm size of solid tumor at some particular time point is completely disappeared from the body. So otherwise, the tumor shrinks significantly but still present. So the tumor, around 80% size was decreasing, but still the 20% is remaining still. So that type of response we can call it as partial response, PR. Try to remember the word CR, PR. Next, the tumor size neither shrink nor grow significantly. The tumor size is not reducing or not increasing. It's stable. Okay. That type of response we can call it as stable disease. Okay. Next one is progressive disease, nothing but instead of decreasing the size, if the tumor size was increasing upon treating our drug. So first 10 centimeter, so after 1 month like 12 or 13 centimeter. So we are giving our drug to reduce the cancer tumor from the body, but instead of reducing, if they increasing the tumor, so that type of response we can call it as progressive disease. Okay, so these are the best overall response. Okay, so here also you can see the best overall response, how many subjects having complete response, partial response, stable disease, and progressive disease. Okay, so here you can see completely, CR nothing but completely disappear from the body. Partial response nothing but around 10% decrease in the size, or 50% on CT, and no new lesions and no obvious progression. SD nothing but not meet CRPD, so it should be stable, and PD nothing but instead of decreasing, if the increasing of the size of tumor happening, so that is a PD. CR is complete response, PR is partial, SD is stable, PD is a progressive. And here you can see some 5 patients who are taking cancer drug. Each patient response was tracking. Okay, so patient 1 you can see CR, so best response is CR. Patient 2 PR, PR, HD, HD. So patient 4 first PR means partially response, then PD means latter increasing. Okay, so first for example 10 mm size is there, so it comes around 70 millimeter, then again increasing like uh, 7 millimeters to again like 10 mm or 11 mm, like that it is increasing. Okay, so first PR means first reducing, later increasing, so the best response is PD only because it is starts increasing, right? So patient 5 first PR means reducing, then completely disappear. Which one is the best response? Complete response means completely disappear from the body. Likewise, some patients during this time point, so first increasing, next later decreasing. So if completely response last, so that is the best response. First decreasing, then after increasing, so the increasing is the worst response. So that will take as the best overall response. So this was calculated in the data set, but for your understanding purpose, I am telling. So here you can see some scenarios. First PR means reducing, next completely disappear from the body. So best overall response is complete response. So first stable. Okay, it is not decreasing, not increasing. During the time point, the tumor was giving different responses and each day, right? So first stable disease, next partial response, then again stable. Okay, so stable to stable, but during this partial response is there. So partial response is the best. First partial response and stable, next progression, next progression. So progression is the best. So throughout the time point, stable is there, stable is the best response. So first partial response, next complete response, next started increasing. Whenever the tumor was start to increasing their size instead of decreasing, that they can take as a best overall response. Likewise, each subject best overall response parameter. So this is the response collected. So they put into the table data set. So we take that information and create the count here. Okay. So let me start the programming first. So this is 1417. Okay, here the efficacy related data sets were separately they stored in the Adam efficacy. Okay, yeah, here you can see this is RS nothing but response related. So here you can see this is the best overall related parameter. Okay, these are the responses. Like here you can see either CR, PD or something. So some patients are not giving response, some patients are giving response. So we can use these responses and represent the table. Okay. Yeah. So first here the capital count of drug A and drug B and treatment comparison. Okay. So first, always begin count, right? So just copy this one and paste it here. So anyway, so here they are asking first treatment, second treatment, capital count. Okay. And up to this was there is no specific what population they mentioned, so you can remove. And here these are the efficacy always perform on the planned treatments only. So if they mention safety population, so you will mention the actual treatment. If something related to the efficacy, so you can give a planned treatment. Okay, so here ADSL underscore. So some subjects are taking drug A, some subjects are taking placebo. And okay, so we are going to do the count. So here, okay, and so begin to so TRT data set, first subject, first treatment, A treatment, 4 subjects, placebo treatment 3 subjects. Okay. So some subjects are taking drug A, some subjects are taking drug B or placebo drug. So capital N count we have derived and created as a macro variable. So whenever it required, so we simply calling that macro variable to represent that count in these places. Okay. So the body part, first we will focus on the best overall response counts and percentages. Okay. So data ADRS merge Adam.ADRS. Okay. And Adam dot so ADSL, because any some such variables are not present from the ADRS treatment related, we can take from the this one. Okay. By use of JID. So most of the variables from ADRS and some variables we are taking from the ADSL as well. Okay. Now first we need to calculate the counts. Simply count how we are calculating by using the proc frequency data equal to ADRS. Okay. By treatment wise tables. Okay. So here what is the response complete, partial, stable and progression? Where this information is available, you can see here. Okay. So this is a character version. They given some numeric version. Okay. So 1, 2, 3, some numbering are given. So wherever the numeric version is available, try to use that numeric version first and character version later, so that it will automatically sort by the numbering wise. Out ADRS underscore aval related table, this one. So what are the percentage will get default? We can remove, just run. So you will get the counts treatment wise, the response wise. So some error. So by we are not putting this one, right? Yeah. So it is not a sorting ascending sequence. So we need to sort the data set before passing into the data set. You can see. So some missing counts also there. So what we do? So we don't require that count. So that is why we write here where aval not equal to missing records, you need to consider. You can see. So first drag A. So CR response count is 1. Partial response count is 2. So and PD response count is 1. So placebo taken SD count is only 1. So total these many subjects have proper response. Okay. So now, so that is a count, but we need a percentage calculations as well, right? So how we done the percentage calculations for previous tables? Small n divided by capital N. So similar way, so we do this here as well. So first, so okay, yeah, this data set name is ADRS underscore aval. So we can give this as a PCT. Now you can see the PCT. So we are not getting the PCT. What happened? Let me check. Okay, here the small n we are giving, right? So here not equal to small n. 1, 2, yeah. Now we can see we will get the percentage. This is the count. This is what the percentage is for each treatment wise, the responses. Okay. So now we are going to represent like this treatment wise, response wise, treatment count. So response here, treatments here. So treatments are in one column. We need to transpose the data set to display the information as per this one, right? So before that one, here we can see here CRPR they mentioned, but here complete text is there, right? And we have to follow this order. So to get that one, so we can customize little bit here. So data, this is related to the section one. So just I am giving call one, set PCT. Okay. First, if eval C equal to, so first one is complete response, right? So if it is a CR, then I am giving variable character version of this one, right? Eval C, okay, character version of this one. So how they want to display the complete response with some space. Yeah, complete response. Okay. So I just giving a stat. It's better. So length of stat giving 200. In not to truncate anymore. So next CR. After that one PR. If it is a PR, partial response. Third one is SD. Stable disease. Next one is progressive disease, PD. So up to what are the data there? So we can display that data. So in future, if anything was added, so we can represent those as well. Okay, PD. Extra. So these are the stats. Okay. So now we will give the label as well. Here we can see the best overall response label is also there, right? So we will give the label as well.
Excuse me, sir.
Data. Yeah, tell me.
Sir, Dr. Sai Tej is waiting in the lobby. Can you please allow him?
Oh, so you people
Thank you,
don't
sir.
have that one, right, to accept because.
No, only the organizer is allowed to accept.
So is it any other way to accept automatically any settings? Do you have any idea?
I will
because
have to take a look at it, sir. I'm not sure on that.
yeah, if anybody know, let me know, because every time I'm in the class, so that if
Yeah,
any automatic option is there, that is benefit for you, right? So
yeah.
I'll also check out of this class. Even previous classes, even the teams, don't have that one, but I don't know nowadays, it is asking admit every time. Okay. Yeah. Thank you for that. Yeah. So label I am creating and this stat. So what is the label to put over this one? Best overall response. Okay. So we want to keep this as the top. How can we keep as a top? Because eval is 1, 2, 3. So what I do? So I am just giving eval equal to 0 so that it will go automatically top, right? And run, and the length of this stat I am giving 200. Okay, so label data set I am creating this one, and I am set this data set to our data set. Okay, so data call one set label data set and call one. You can see best overall response here because it is 0 and remaining all the here. So now I am using the transpose procedure to get as per the structure. So let me use transpose. Yeah. So here call one underscore T. So ID is treatment and this is GRP and by variables are here. So eval and this one stat. Okay. And sort by these two. Now we can say call one and call one underscore T. Due to missing value. Yeah, so it's not a problem. We will see. Okay, due to missing value, but we are getting the proper structure. So you can see best overall response. These are the response, first treatment and second treatment. So now we can see the first section, best overall response, drug A and drug B counts and percentages they are asking. So this statement comparison related to this one, not this one. Okay. So first section, first set of section we have completely done. So this is the first and this is second. Where are the responses are missing? So we can keep it as a 0, but not in the first line, second line also because this is a label. Okay. So we can keep as a missing. Call one underscore T. Okay. So first and second treatments are missing. So keep it as missing, but it should be eval greater than 0 cases. Then do n. So that wherever the missing values are there, so we are applying the zeros. But in the first line it is a label. Here you can see the first line they are not asking anything. Just this is a label under this label. So we have responses. Okay. So now these are the counts and the first set of section we keep it as it is. Okay. So this section I am giving number 1. Why? Because this whole set we can consider as a 1 and this whole set consider we have a 2. Okay. So main order equal to 1. Okay. So that while doing proc reporting, this complete section we can consider as a 1. Okay. So this one next to second section. Okay. Fine. So first section was done. Next section, what is best objective responsive rate? So overall response nothing but which response giving a best response. ju- Sorry. So what is the best overall response is the best treatment response of a patient achieved during the clinical trial. Okay. So what is the response achieved during the trial? That is the best overall response. But what about this best objective response rate? Nothing but is a major used oncology clinical trial. So it is a percentage of patient who shrinks, means either partial response, either CR. So who got CR, PR or CR, partial response or complete response, those subject percentages they will take into the consideration. Okay, here you can see. So for drug A here, what we get in the output. So complete response is one subject and partial response is two subjects. So total three subjects. So 50 plus 25, 75% of the subject will get the either CR, either PR. So here 1 plus 2 divided by 4, total 75 percentage. Okay. So this is, we can call it as overall objective response rate, or nothing but objective response, complete response plus partial response divided by total number of patients. How many subjects got CR and PR divided by total patient. So total is here how many subjects uh, for drug A? So total drug A 4 subjects. Okay, out of 4 subjects, 3 subjects were got CRPR and 1 subject is PD. So whenever we calculating the objective response rate, so CR plus PR divided by total patient, 3 by 4 into 100, it is 75. But drug B, so there is no subject, so 0%. That means what? 75% of objective response rate for drug A, 0% is this one. This objective response rate is helpful to compare the effectiveness of different cancer treatments. Okay. So here, okay. So first we'll see. So this is the first line you can see objective responsive rate. Nothing but so either CR, PR response divided by total number of subjects, that will give you the best objective response rate. Okay. So next 95% is nothing but so here. So what is 95% confidence? So what is the result you got in the particular above section? So here counts and percentage you will get, right? So this percentage we will say that is 95% accurate. Okay. For example, 75% you got. So here you will say that okay, so it should be around some range to some range, like 40 to 80% range. We are getting 75, right? So we are telling that 95% accurately you will get the value from the 40% to 80% range. Okay, because we are doing on few subjects, and this results we are going to apply large number of people. So that time we need to say some confidence because we are testing on few subject, right? So in the clinical trial, so we would say 95% accurate results are these by using this 95% confidence. So by applying this procedure, so we will get the percentages. So that percentages in between you will get this percentage. 75% mean so you will get the 95% confidence, like 40 to 60%. Okay. So for example, here 6 out of 10 patient has tumor shrinkage. So 60% of the drug A. Okay. So 10%. We don't know 100% sure the results are correct or not. We don't know the 75% correct or not. So by applying this 95% confidence interval syntax, we will get this result. So you look that result. Okay. If the results are saying your value between this one means that 95% sure you will get the value from this one range to another range. Okay. So we are applying small number of patients take into the consideration of the clinical trial. That results we are going to apply large people. Okay. So next here you can see so 95% CI, drug A and drug B. Okay, we after getting the result, we'll see this one. So second section is this section, best objective response, either CR, either PR. Okay, so data, okay, ADRS with ADRS. So ADRS only having entire information, right? Yeah. So I'm giving ADRS 2. So what they mentioned, CR, PR in one group, right? CR and PR in one group. So what is the CR and what is the PR here? CR they given one number, PR they given two number. So that is why if a val in 1, 2, then I am creating one variable like obj objective response rate 1. Okay, else obj equal to 2 I am giving. Okay, just I am creating CRPR into one group and another is the another group. Now I am calculating clock frequency data equal to ADRS2 by treatment and tables. This objective response rate. So out equal to this is ORR related. So just give the RS like 3. Now we can see. Okay. So some now we can see drug A having 3 subject OBJ1 and here drug A second response 1 and placebo 1 subject. Okay. So what is the percentage you will get? You can drop and we will calculate the percentages manually. Rename equal to count equal to small n. So RS3 this is a count. Okay. So how to calculate the percentage? Same way. So RS3 and here we'll give PCT. You will see the percentage. Okay. So first treatment objective response rate this one. So here in this line, what we are going to represent? Only CRPR. That means what? OBJ1 and these are the two. Okay. So this line we are going to represent only the eval equal to 1. The OBJ equal to 1 means objective response rate. Okay. So here, so this line CRPR related result, right? obj equal to 1 results. Okay. So data ECT3 set ECT2 if obj equal to 1. So PCT3, now we can see only this one. So this response we have, because there is a second treatment, we don't have any OBJ1, right? Only one treatment. So what I am going to give here, so yeah, so this we can call, so this is a second section, and in that second section first line. So I am giving column 2 underscore 1, so that second section first one, we can assume this one, call 2 underscore 1. Okay. And using the transpose procedure, to represent the treatments in a column wise, right? So call to underscore 1 underscore t. Okay, so everything we are representing the treatment wise. This one is variable group and this one p, and here so by variables, right? So by variables we need this one. This text is needed. Okay, so stat, and next this is the, what is the main order for this one? Second, because it's the whole second section, right? So main order, and next stat, and this we are giving first one, right? So aval equal to 1 I am giving. So call to underscore t. You can see main order aval, this is the start and this is the first treatment. Okay, so here you will get, if the response is there here also you will get, if the information there, automatically second treatment also will get. So this first line was done. Okay, so one by one line we need to do in the efficacy. Okay, so call to second section, first line, we will done the data set. Okay, so next second line we are going to do. So 95% of objective. What we are getting this 75%, whether 95% accurate we need to prove. Okay, yeah. 1 minute, I'll be back. Sorry. So 95% objective response rate. For to get this one, proc frequency data equal to, so here which data set we are using, ADRS2, Same by treatment 01PN and TRT01P. And next tables, this objective response rate variable. So you can use the syntax binomial and exact method we use to get the 95% of confidence interval, 95% of object response rate. So use the binomial and exact method. Okay, just run. So while running this one, TRT01, you will get some statistics in the output window. So how can we get the statistics into our work library? So you will run ODS trace on and ODS output delivery system we are tracking trace up. So that once we are running this trace on trace up, what happened? We will get this information in the log window which data sets were created. Binomial test, binomial CLS, binomial like that, data sets names which created. So you will get in this data set. So confidence limit related information was there in the binomial CLS data set. So we take out that information outside. So ODS output the data set. So you can give any name with the Lark library. So here I am giving confidence limiter. So uh, CI for objective response rate. Okay. So I am giving CI ORR. You will see the responses. First treatment and this Pearson method. So this is the lower 95% confidence interval and this is the upper. Okay. So now lower and upper. How they want to represent here, you can see lower dash and upper value for A and B treatment. Okay. So these are the values in the numeric form. So we try to convert them into the character and concatenate and represent. Okay. So we can do the customize here. So data CIORR, let CIORR, you can give another name and confidence interval equal to, so put off this lower CL, 95% of lower confidence limit. So they want to represent almost 4 decimals, I hope. 1, 2, 3, 4. Okay. So just giving 4 decimals and concatenated with the dash and put upper CL 6.4. Okay. So the start variable, the label variable here is 95% CA. Fine. And next, the main thing so main order is, this is completely second section and we have to give the second position, right? So this is complete second section. This is the first and this is the second we need to represent, right? So that is why aval I am giving 2 and run CIOR2. So this is CI lower dash upper. Now we need to use the transpose method to get the same layout. Okay, so same transpose method. So this I am giving column 2 means second section, second line transpose. Okay, and main order aval stat and treatment. So this is the CI. Now we can see 95% object response rate, first treatment, second treatment values. Okay, this is the second section, second line. Fine. Next, come to the third one. What is the difference in objective response rate? So this was will get a objective response, this was will get a objective response. So what is the treatment related comparison, A and B? What is the difference in objective response rate? Okay. So difference in objective response rate, how to get? So just copy this section. Okay. So now tables. Okay. And this objective response, how to get the difference between this one? By using the keyword risk diff. Okay. So if you are not aware of this, keywords, you can ask statistician. He will explain you. So if you are, it's initial stage, if you are doing some efficacy analysis, so the syntax part to get the efficacy analysis starts will help you. Okay. So by this running this statement, risk difference, so you will get backend data set in this risk call one and call two. Okay. So just, risk call one. So I am giving risk one. Okay. So just I want to check which data set having which information. So I'm putting two data sets, risk one, risk two. What about this one? Risk one, you will having this information, and risk two having this information. Okay. So in the call one, you will see here treatment comparison, right? Difference in the treatment comparison. You will see the risk. Okay, risk here, and you will see the risk also here. So first treatment versus second treatment we are doing. Okay, so first treatment versus second treatment. Second treatment is a placebo. So first treatment is our actual drug. So what we do? So we will take this column one. So this is a column one. So that is why we are taking in the column one, not in the column two. Why? Because so here in that our data set ADSL. So first one is the drug A, second one is the placebo. So first versus second we are doing. So that is why we take into the column one. So second versus first, if we are taking column two, generally we take. But here actual drug versus placebo. Placebo means a dummy drug. So some subjects they given dummy, some subjects they given our oncology actual drug. So that is why we take into the column one. Means the first treatment related information you will take into the consideration. So data risk one underscore one set risk one. In this, if row equal to, so here you can see the row equal to, so what means difference? Okay. So we are going to do the difference in objective response, right? So different row you will find. So let me check with the second reference also. So difference, this is a minus zero point 0.7, here positive value. Okay. So difference. So here I am giving convert them into the character. So what is the value? Risk is the value. So risk. So up to 4 decimals. And the start I am giving the label 95 per difference in the objective response rate. And the main order equal to 2 and our equal to 3 because third line we are going to print, right? So this entire is second section, 1, 2, 3 is the this section. So and so we will give third treatment as this RR. Why? Because so first and second treatment we are going to represent, right? So this is for third treatment. You can assume first and second. This is third place we are giving. That is why underscore 3 I am giving. So risk 1 underscore 1. So this is a third. Now this is start. This is the main order. This is our. So now we are applying proc transpose procedure to get the same structure. So every time you just apply the transpose and set the lines. Okay. Risk underscore 1. And this is a column to third line. And this is a underscore 3. Instead of 3, just simply if you are assigning this as 3, so automatically it will give a 3. And where is RR? Let me try in this way. Column 2 underscore 3. You can see. So main order aval and start. So this is a 0.7500. Okay. Yeah. So this line also done. Next 95% CI for objective response rate. What is the second line? 95% this one. Difference in objective response rate. Okay, so this one 95% objective response rate, nothing but here. So while doing this process, you will get the risk one, right? In that risk one, you will see this is the difference. And here you can see lower and upper CL, right? So this value you can give as a 95% confidence limit of this differences. Okay, so this 95% object response nothing but this difference related. Okay, so what I do, so this risk one, yeah, so we can copy this code, we do some update. Okay, yeah, here the risk one data, so this line is completely they want to print the risk value. So along with this one, the risk value related lower and upper values they want to print here. Okay, so the risk data set risk one. Okay, so in this we are keeping only the row difference. Okay, so next CI is lower and upper CL. So main order to aval equal to 1, 2, 3, fourth line I am giving. Okay, so this one you can give as risk one, something like a 4 you can give. Risk underscore 4. So lower value and upper CL. CA. Okay. So this is a which line? 1, 2, 3, fourth line. So column to fourth line. ERT01 PN not found. This is thought treatment we assume, right? Simply all to 4. Okay. So this one. 1, 2, 3, 4. So up to now, what are the data sets we have created? So let me collect together so that you will get some idea. So final. Okay. Set. So first information, best overall response related all this one. What is the data set we created? Best overall response last data set is here. Call 1 underscore T. And second set, call 2 underscore related all the data set. 1, 2, 3, and 4. Okay. Call 2 underscore 1 underscore T and second line and third line related data sets and fourth line related data set. Okay. Now you have an idea. Final. The final data set you will see. So best overall response related all this one. Next, best objective response rate and 95% objective response rate. And here the difference objective response rate and what is the 95% object in the difference cases. Okay. So here you can see up to here we done. So last one is the p-value. So how to calculate this p-value? So p-value. So p-value nothing but probability value. So by writing the proc frequency only we will get this one. So we will take the proc frequency. Simply copy this code. Okay. ADRS2. So treatment wise. Treatment wise. Objective response rate. So we are using here the CMH method to get the the p-value. And so let me comment this one. By writing this one, you will get the p-value. So p-value you will get in this CMH data set, coherent mantle Hansen statistics. So in the CMH, you will give the data set like CMH. Okay. So the data set name CMH here, you will see the probability value. In this, generally we prefer row mean square differ. Okay. So we'll get a 3 p-values. So if it is the same also in future you may get, so some deviations are happening. So that is why we will pick the only the alt hypothesis equal to row mean square differ related value. So only one p-value we are going to represent. Okay. Now we can see the data set name what we given CMH, right? Yeah. So this probability value what we get, so we are going to represent. This is a prob nothing but probability value. So what I do here, So data P set CMH. Uh, yeah. So main order to eval place is 5. So treatment is 3. And the start is P value. And the P val P1 P val equal to, so put of prob prob number 6.4. We can see P value we created. Now we are transposing the data set to get the treatments. Okay, so the var is P val, and here the data set name is P, and finally fifth row. So now the P value, this is the P value. Now we added this also into this here, fifth row related statistics. And final data set now ready to print into the RTF file. Okay. So here we are giving, so main order means this everything in the first section, this everything in the second set. So in the second set also we are giving the numbering 1, 2, 3, 4, 5. So that so it will won't change while using the proc report section. And here also eval also there. So this will follow this order as per the table. Okay. So this is the first treatment, second treatment. This is a comparison of these two treatments. These are the values. Now we simply write the proc report section as usual, like other data set how we are writing. So similar way we are writing here as well. So just copy this, and the title 3 is this one, and this is 1417 1417. Okay. So proc report section, just copy this entire section and will update one by one. Yeah. So anyway, 3 treatments are there. So no need this to delete it. And here also 1, 2, 3 is enough. Delete it. So the first one is main order. Next, and after this one, so we need to print the eval, because eval also sorting purpose. Next, stat is the character version we should represent. Next, 1, 2, 3. 1, 2, 3. Okay. So this main order, no need print. Next, eval also no need to print. So which one we are going to print? This stat. So the label is, they are not mentioning any label. So keep it is missing. And so first treatment, begin 1, begin 2, this drug B. Okay. And third treatment, they want to give a treatment comparison. And so above one line and below one line. Let me see how this report was going to generate. And here, this is a final. You can see best overall response. So first section, second section, I want to give some space. Compute before main order line, giving the space, and end come. We will give some space. Okay. So now this is the result. So each and every response wise count. So this best overall response nothing but CRPR 1 plus 2 3, and this 95% nothing but, so this 75 is accurate or not. Here 0.19 to zero point 0.9 nothing but, so 19 percentage to 99 percentage. So if it is converted into the percentage, 19 percentage to 99%, this value will get, like that it will give. Okay, so this is the difference nothing but, so these two differences 75% around. Okay, because it is a 0 and it is a 0 and it is 75. That is why the difference around 75%. And this 95% nothing but, this difference related value should be, 32% like that. Okay, so p value you are getting 0.22 around. Here the p value, whenever the p value is less than 0.05, if you are getting, okay, less than 0.05 getting, that means there is a significant difference between the first treatment and second treatment. But here we are getting around zero point 0.2, greater than the 0.005. So that is why there is no significant difference, because we are doing on some smaller sample like 4 and 3 only, right? So that is why. So by getting this result as per the statistics we use, so that's saying that there is no difference between the drug and A and drug and B result. There is a not significant difference is there treating with the B drug and A drug. Okay. So if the significant results you are achieving, so your p value should get below 0.05. Okay. So every time you will check with any table p value there. So if the p value is less than 0.05, then only we say that the using drug with the comparing drug having the significant difference. Okay. So here 95% difference in the objective response rate. So you will get the 0.3257. That means what, So 32.57 chance of the drug is A is better than the drug B, because we are comparing with the A drug with the B drug, right? So 32.57 is, A drug is better than the drug B, but there is no much significant difference. That is why we'll get the p value. It is a better, but we need a significant difference. So out of 100 students, 80 students should pass. Then only it is a significant difference. Okay. So like that, we are expecting not a difference, significant difference we are expecting. Here 32.57 percentages, a drug A is better than the drug B, but we need more. Okay. And so 75%. Yeah. So this is what the table of complex, efficacy related oncology study. If any oncology study, if you take, so this objective response rate, overall response related table, we need to generate. So how the tumor was responding, the responses wise results we need to produce. After that one, so CRPR, complete response versus partial response, how many subjects are there? So that we can call it as best objective response. Okay. So, and then we can cross comparing with the two treatment and get the p value. That p value show whether really significant difference between there the first treatment to second treatment. So this is a little bit tough table, I know, but so whenever you want to go with around about 2-3 plus experience, so most of the SAS programmers done safety table. But what is your difference? If you know the efficacy, there is a more chances to recruit you. Even if you explain this one, even 5+6+ SAS programmers are unable to do this type of table by their own. Okay, that is why if you learn this one and you are speaking this table in front of interview, definitely they will recruit you. Okay, each and every step I explain. If you are not able to understand, watch this recording video again and again and try to produce this table by your own. And whenever any chance, put this into your resume, and if the questions related to this table, in the interview, if you are explaining in a better way, so they will definitely recruit you, because most of the SAS program nowadays, they don't have a knowledge on the efficacy oncology. They have knowledge on the oncology safety side, but most of the candidates, they don't have oncology efficacy knowledge. If you try to speak, so definitely it will useful for you. Okay. So now you are done. If anybody having any doubt, just unmute and ask me one by one.
Yeah, hi, sir. Good morning.
Yeah, tell me.
Right, sir. Yeah, but actually here we are transposing the data, but we are getting one warning in log warning. So real time, if we having that issue, it will generate the log issue. So how can you clear that?
So where this one? So I have removed. Yeah. So this one, not like that.
Yes, yes,
So
yes, yes.
this is
Or,
no output
no, no, no,
destination.
no. Above one. Maybe I think transpose the data.
Yeah, here, right?
Where we are transposing? Yes, 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 boss.
So here, for example, call one.
Yes.
Okay. So here, this something related to this missing values, right? So we can avoid what we do. So first you need to take this one and transpose, then add this label also fine. So that will avoid this problem. Okay. So due to this treatment, you are getting the problem, right? So what we do, so why we are getting this warning? Because the ID value having this ID value having missing value. Okay. So what we do, you can replace this missing with the 99 and you can transpose and you can again, for example, we'll show you how to handle this one. Where it is, not this step, sorry. Call one here, right? Yeah. Okay. So call one data in this treatment, we have this is the missing value. Okay. So after call underscore T, so this one, two, yeah. So simply you can assign here this label data set. Yeah. So here TRT01 n equal to 1. Okay. Yeah, there is no issue here. You will get same response. Okay. So because due to that ID value, ID in the sense, so which ID variable you are using that has some missing value. Now we just assigned it as a 1 first treatment. Okay. So obviously this is just for label purpose, right? So that is why you will get so the missing values of IDs are missing. Okay. You can assign any one number so that it will we can clear the warning messages. Okay. Even that was not impacting our table. That is just label and we want to put that label at the top row. Yeah. Anybody having any other doubt?
Yeah. Thank you, sir.
Yeah.
Sir,
Yeah. Tell
in
me.
the output that TRT01, we wrote 1, right? It's
Mhm.
showing, don't you think we have to take it off, like make it blank? Should we make it blank finally?
Yeah. Which one? Here. This one. After
Yes.
transposing here. This one, right?
Yes, sir.
Yeah.
So,
It's here. You can see after transposing the data set. So here first and second. So anyway, the first we don't have any values. Okay.
okay.
So this is
Thank
just for label. And here the output also this is just for label. We are not representing any values under first and second treatment. Okay, just I'm adding that label. Okay.
Thank you, sir. Understood.
Yeah, please go through this table carefully. This is the most important table. If you are putting in your resume this table, definitely they will ask you questions on this, because this is a major, because solid tumor related, how the responses, how the p-value is more useful. Okay, so yes, first time bit complex, lengthy code, but still you have to practice to get the efficacy knowledge. You can ask any SAS programmer in the industry how the efficacy tables. Did you work on the efficacy table? Even my colleagues who are having 10 plus, they are not working on the efficacy still. That is why, so they are, lacking some SAS project related stuff. So I am teaching you in a better way. So explaining these efficacy tables as well, so that you will get a knowledge. So whenever you go outside, so your resume should be weightage with the efficacy knowledge. Okay. Yeah. Tomorrow we will discuss one more efficacy type of oncology related efficacy table. Okay. So we'll meet you same 6 a.m. It will take around 1.5 hour time tomorrow as well. Okay, please join in the early. Okay, so I'll also, if anybody know how to accept the invitation candidates in automatically, please let me know, so that in every time so you are not going to wait in the lobby. Okay.
Yes, so I have a small doubt regarding this.
Yeah, tell me.
But actually, yes, here we are using only Frog Freak, but if we wanted to use the Frog Gen mode or some another
No.
procedures
Here you
also.
can see based upon the tables, so the procedure will decide. Okay, so most of the time the
Okay.
statistician will tell you the procedure. So which procedure is best
Okay.
suitable to for this data and this procedure. That will there in the SAP
Okay.
document sometimes. Otherwise, we will ask the statistician to provide the procedure. Okay, so here this table, this procedure only fit. Okay.
Okay. But actually, yeah, if we get the chance to use the Frog Gen mode procedures also.
Yeah, so based upon the statistic, because stats will decide the procedure, not programmer, right? So if the stats want to use the gen
Yes.
mode
But
procedure,
actually,
okay, so we will
uh,
use that procedure. Okay, if you don't know the
yes,
syntaxes,
Siva.
the statistician will provide the gen mode code if they want to use, so we will use. So because safety side we can use n number of procedures we can use, but in case of efficacy, the starts will is the main point of contact too, and we will ask the procedure we'll use. So this was with my knowledge, so I write the syntaxes, but in a complex efficacy related procedure we will depend on the starts. Okay.
Yes, I agree with you. But actually, here, if we wanted to use any general procedures, just for our experience or how to use that, you know that.
Yeah, if any gen mode procedure related code is there, we'll share definitely. Okay.
Thank you.
Yeah. Yeah. Thank you so much, guys. We'll meet you tomorrow at the same time. Thank you. Have a nice day. Bye.
Thank you.
Yes, sir. Thank you.
Thank you, sir.